Hello, everyone. This is our presentation on improving racial bias in hospital ICU mortality prediction. And this is by Elijah, Tiantian, and Tianqi. For the motivation of this project, we know that intensive care units, or ICUs, use illness severity scoring systems for benchmarking and case mix determination decisions. And especially in the COVID-19 pandemic, these scores are used in predictive models for allocation of scarce resources. However, the research done so far, as shown below in the two publications, shows that there is racial bias in predicting mortality, and we want to address this in our project.
In order to find the most efficient model for our prediction, we adopted 4 steps, including feature selection and data cleaning, model selection, hyperparameter tuning, and model assessment. The original dataset contained 17 features. We removed all 5 timestamp features because the dataset is anonymized for privacy purposes, and thus timestamp features are altered in a way that they may not reflect the actual correlation between features such as admitted time and the death of the patient. Then we removed all identification information as it is not relevant to our prediction. Then we discarded irrelevant categorical features such as language. Then we converted categorical features to binary numerical features in order to apply more models to our dataset. In the end, we normalized all features using sklearn standard scalar. In order to reduce the redundancy in our features, we used the heat map to plot the Pearson correlation between all pairs of features in our dataset. And as you can see here on the graph, no correlation has an absolute value of more than 0.5, which means there are no strong correlation between any features, so we did not have to delete any feature.
The second step of our approach is to do the model selection. Since the output label for our dataset is binary and the features are numerical values, we are considering the following models: the KNN classifier, decision tree classifier, logistic regression classifier, random forest classifier, and the Gaussian naive Bayes classifier. The third step is hyperparameter tuning. During this step, we will use k-fold cross-validation for different parameters for all the models, and then we will calculate the misclassification error for each of the k-fold, and then got the average accuracy for different models and select the best parameters. For KNN, we got the best parameter, which is k equals to 10. And for decision tree, we got entropy, max steps of 10, mean sample leaf of 100. And for random forest, we got the best number of trees of 400, criterion entropy, maximum depth 20, minimum leaf 50, max number of features 17, and we will use bootstrap and also the out-of-back samples.
We used the ROC curve in order to visualize the performance of each model. From the graph, it is obvious that KNN performs much poorly than all other models. Thus, we filtered out KNN in our next step of assessment. Then we applied 2 different metrics to determine the performance of each model. We also added one more model, the ensemble model, which predicts one sample by taking the mode of the prediction down on that sample by all other methods. In the accuracy column, we can see that random forest prediction has the highest accuracy. It also has the highest AUC score. Thus, random forest is our optimal model.
Once we've determined that the random forest was the best in accuracy and AUC, we went and trained that model and tried and tested it for false positive misclassifications using our testing and training data set used for the simple logistic regression we use as a baseline. And we found that even though we have a better accuracy and a better AUC, it actually predicted more false positive misclassifications than the original model used by most hospital systems. But to conclude, even though though the accuracy and error of the optimized random forest model was better than that of the simple logistic regression model, the random forest model did a little worse and predicted more false positives than the baseline model, unfortunately. So other ways to improve racial bias in predicting hospital mortality is suggested instead, such as modifying the SOFA score or even using different illness severity score. Thank you for listening.